Hello, my name is Beth Dixon, and this is a video series based on Vicki Borlaug's PowerPoint presentation on hypothesis testing on the mean. We are looking at problems with x normally distributed and sigma, or the population standard deviation, unknown, and I wish to thank Mrs. Borlaug for allowing me to use her PowerPoint to make this set of videos. And this is part 2 of the series. And since I had to stop directly in the center of a video, I'm going to quickly go back through what we've covered. We learned the 5 steps that we're going to use, which is to set up the hypothesis, define the critical region, use the data to define the test statistics, and based on the data make a conclusion of reject or do not reject the HO, and then to write a sentence in terms of H1. We're going to use Mrs. Borlaug's structure to organize those 5 steps. And we're looking at an example where a manufacturer produces ropes. The breaking strength of the rope is normally distributed, and a random sample of 10 ropes is taken, and their breaking strength in pounds is measured. And using a 0.05 level of significance, we're testing the claim that the mean breaking strength is less than 300 pounds. We took the data, and using our calculator, we found the X bar, or the sample mean, is 298.3. The sample standard deviation is 16.1180, and the sample size N was 10. And we set up the hypothesis and the null. So the alternate and null hypothesis, I'll get that said right, which gives us the null hypothesis is that the mean is greater than or equal to 300 pounds, and the alternate is that the mean is less than 300 pounds. And we had defined the critical region and looked up that in the table and got a negative 1.833, and that gives me a about 2 minutes to review what we covered in the previous video. But let's pick up right there. So our information so far is that we have our hypothesis and we have defined our critical region using the alpha risk. But what does this picture that we've drawn tell us? Well, basically, we have drawn a line in the sand. We have divided our normal curve, our bell curve, into 2 sections, a shaded section and an unshaded section. We have a dark side and the not dark side. So what does that give us? Well, if it falls, on this case, to the left side where we have shaded in the area I've indicated here, if HO is true, any value that falls over here, these values would be unusual. That's what we're saying. In this area, if HO is true, these values would be unusual. If HO is true, the values to the right here, these values would be ordinary. If the data gives t values less than negative 1.833, then we would reject HO. If the data gives values greater than negative 1.833, then we do not reject HO. Basically, it's dividing our normal curve into ordinary and unusual sections. If HO is true, it would be unusual to get values in the tail. If HO is true, it would be unusual to get values in the tail. If HO is true, it would be unusual to get values in the tail. If HO is true, it would be unusual to get values in the tail. And again, Ms. Borlaug has used repetition to help you remember something. So, if the test statistic, which we'll abbreviate TS, gives a value in the tail, then we will reject HO because it would be unusual. And I like to say it because it falls in the dark side, we will reject HO. Now we're on to step number 3, which is to actually find the test statistic. Our critical region is our decision-making tool, but we must have the test statistic from our data to make that decision. So what information did we get from our data? We got the sample mean, X bar, is equaling to 298.3. Our sample standard deviation, S, is equal to 16.1180. And our sample size, N, is equal to 10. Our formula to find our test statistic is N equals X bar minus the mean, or mu, and that says mu sub 0, but that's like the null, and divided by S divided by the square root of N. And that's a lot of things going on, but notice how similar it is to the formulas that we've used before for Z and T. It takes the data value that we found minus a population data value divided by the adjusted standard deviation adjusted for the sample size. Mu sub 0 is the claimed mean. So we put in the claimed mean, which in this case we claim that the mean is 300 pounds. So that's going to be 298.3 for our sample mean, 298.3 minus 300 divided by the standard deviation divided by the square root of 10, which is our sample size. To do it in the calculator, especially if you're trying to do it in one step, you will need parentheses around both the top and the bottom. That keeps your order of operations safe. So please use the parentheses on the calculator, and when you do so, you should get a negative 0.334. We do take this out 3 decimal places because our critical value is 3 decimal places. Step 4 is based on the data, and it is time to make a conclusion. And to make this decision, we take the test statistic from step 3 and place it on the graph from step 2. So here's our graph, and we want to decide whether our test statistic falls into the dark side, into the reject HO region, or the do not reject HO region. Well, where does the test statistic of negative 0.334 fall? So compare it, and you notice that it does not fall in the dark side. It falls in the do not reject HO. So our conclusion is do not reject HO. Notice that word not. We are now ready to write our sentence in terms of H1. Doing the work is only part of the procedure. We need to understand what our real conclusion is in regard to the problem. To do this, we want to write a sentence about our claim. The first part of the sentence always refers to the alpha risk and is the same other than the actual number for the significance level. So the first part of the sentence always refers to the alpha risk and is the same other than the number itself. So the first phrase should be using a in our case, 0.05 level of significance. If that level changed, you would just change the number, but that phrase stays the same. The next part of the sentence, and again, this identifies the alpha risk. The next part of the sentence, Ms. Borlaug wrote in two parts, but I want you to just look at the first part of this. There is enough, in this case, there is not enough evidence to say. For Ms. Borlaug, she wrote it all as one. For me, I want you to just look at there is not enough evidence to say. If we do not reject the null, then there is not enough evidence to say. One not leads to a second not. If we do reject, there is enough evidence. If we do not reject, there is not enough evidence. You see the connection? And then the last part of the sentence is to repeat what the claim says. To say what? That the mean breaking strength is less than 300 pounds. So what have we said? Using a 0.05 level of significance, there's not enough evidence to say that the mean breaking strength of our rope is less than 300 pounds. We do not have enough evidence to make a conclusion about our breaking strength. And before we stop this video, let's review the steps from the previous problem in our structure. We have our example, which is a manufacturer produces rope. The breaking strength of the rope is normally distributed, and a random sample of 10 ropes is taken, and their breaking strength in pounds is measured. And using a 0.05 level of significance, test the claim that the mean breaking strength is less than 300 pounds. So using your 1-var stats, you have your X bar, your S, and your sample size. And you'll write alpha is 0.05, and you should also write what the claim is, which in this case we're testing the claim that the mean is less than 300 pounds. Then you will write that structure that I talked about. You will write your little boxes just like you see on the screen. And labeling those as your 5 steps may be also helpful, especially as you start out. Remember that our hypothesis, since the claim is what we want to prove and does not contain a condition of equality, it will go into H1. Less than 300 pounds, mean is less than 300 pounds, gives us mu. Less than 300 pounds gives us the opposite of that, which is mu is greater than or equal to 300 pounds. Then we can draw our critical value curve, our normal curve, and put our critical significance level 0.05. Since our H1 says it's less than, that's a one-tailed, left-tailed test with all of our significance in that one tail. I won't repeat looking up the critical value, but we will remember that it's negative 1.833 based on the significance level of 0.05 and degrees of freedom of 9, which gives us the reject and do not reject regions as indicated. Our test statistic, we have our formula, and plugging in our numbers, we get negative 0.334, and with a quick little arrow, we see that that falls in the do not reject region, which gives us our conclusion of do not reject. Notice how we put that into the 4th of our boxes. Then we're ready for our 5th box, starting with using a 0.05 level of significance. Notice that because we have a not here, we'll have a not here. There is not enough evidence to say what? That the mean breaking strength is less than 300 pounds. And again, we just repeat this from the problem. And this is a good place to stop. Please join us for part 3 of this PowerPoint in the next video.